Question 11. I kind of like question 11. Question 11 deals with logs, which is one of those things that a lot of people don't have a good foundation with. They're really not as complicated as they seem, and they're kind of fun once they click, but for a lot of people, it just never clicks. The key thing to know about logs, like the log base 3 of 2, for example, is that this thing right here is an exponent. What the hell do you mean it's an exponent? It's a power. Specifically, it's the power that you'd need to raise 3 up to if you wanted to change it into a 2. So picking on some numbers that work out a little bit nicer, the log base 2 of 16, for example, would be equal to 4. Why? Because the exponent that you need to raise 2 up to, if you want to change it into a 16, is a 4. 2 to the 4th power equals 16. If you really struggle with reading this and understand that it's asking for the exponent that you need to raise 2 up to change it into a 16, you can switch from what's called logarithmic form to exponential form. This equation represents logarithmic form. This equation represents exponential form. More generally, the log base b of x equals y is equivalent to the statement b raised up to the y power is equal to x. This thing is an exponent. It's the power, y in this case, that you'd have to raise b up to if you wanted to change it into an x. All right, b to the y equals x. Logarithmic functions are really closely related to exponential functions. In fact, they're inverses of each other in kind of the same way that x cubed and the cubed root of x are inverses of each other. And the fact that they're inverses means that if you compose them together, they're always going to cancel each other out. Maybe to use function notation, we'll call this one f of x and we'll call this one g of x. If I compose these together, f of g of x would be f of the cubed root of x, which is saying copy this expression f of x, but change the input, all the x's, into cubed root of x. So I'd have the cubed root of x cubed. F of g of x is the cubed root of x cubed, but the cubed root and the cube cancel each other out. It's just equal to x. And that's not specific to these functions. Anytime I compose together a function and its inverse, I'm always going to get x as the composition. And it doesn't matter what order you compose them in, g of f of x is also going to be equal to x. Don't believe me? G of f of x is g of, we'll replace f of x with what it's equal to, x cubed. And then we'll evaluate g of x cubed, copy this line, but change all the x's into x cubes. I got the cubed root of x cubed, which much like the cubed root of x, pause, cubed, is equal to x. When you compose a function and its inverse function together, you always get x. How does that help us with this problem? Well, if you consider the function f of x equals the log base, 3 of x, sure. And the function g of x is equal to 3 to the x power, in the same way that these guys are inverses of each other, these guys are inverses of each other. So if I compose them together in either order, I'm always going to end up with x. If I consider f of g of x, that would be f of, replace g of x with what it's equal to, 3 to the x power. Evaluate f of 3 of x by copying f of x, except changing all of the x's in this expression into 3 to the x power. I got the log base 3 of 3 to the x power. This has to be equal to x because I'm composing a function and its inverse. Similarly, g of f of x, which would be g of the log base 3 of x, which would be 3 raised up to the log base 3 of x, also has to be equal to x. These are facts that you can just memorize. They're log identities, but you don't need to memorize them because if you kind of think about it, it really makes a lot of sense. Think about what this thing right here is saying. The log base 3 of anything is asking you the question, what power do you have to raise this base, the 3, up to, if you want to change it into 3 to the x? What do you got to raise 3 up to if you want it to be 3 to the x? Well, x, because 3 to the x would be 3 to the x. The log base 3 of 3 to the x is equal to x because this 3 raised up to this x is the same as 3 to the x power. Maybe that's easier to see with numbers. What is the log base 3 of 3 raised up to the 12th power? This is asking you the question, what power do you have to raise this 3 up to if you want to make it 3 to the 12th power? And you're like, problem, I don't know what 3 to the 12th power is. You don't need to know what number this is equal to. The answer is 12 because this 3 to the 12th power is equal to 3 to the 12th power. And if that makes your head hurt a little bit, it's going to hurt even worse in just a minute, because if you consider this form and why this is equal to x, it's even more interesting than this one. What we're doing here is we're taking this 3 and we're raising it up to a power. Oh yeah, what power are you raising it up to? I'm raising it up to the log base 3 of x. Wait, what is the log base 3 of x? The log base 3 of x is an exponent. It's the power that you'd need to raise 3 up to if you wanted to change it into an x, right? Instead of a 2 here, if there was an x here, instead of a 2 here, there'd be an x here. So this exponent right here is that special exponent that you'd have to raise a 3 up to if you wanted to change it into an x. So if I take 3 and I raise it up to that special exponent that 3's need to be raised up to change them into x's, what do I get? Well, I get an x, kind of by definition. You want to see numbers? Sure, I'll give you numbers. What is 3 raised up to the log base 3 of 81? Well, this answer is going to end up being 81. Why is it 81? Because I'm taking a 3 and I'm raising it up to the special power that 3's need to be raised up to change them into 81s. What is that special power that 3's need to be raised up to change them into 81s? Well, it's a 4, right? Because this 3 to the 4th power is equal to 81. So the log base 3 of 81 is just 4. So this expression is 3 to the 4th power. What's 3 to the 4th power? 3 times 3 times 3 times 3 is just equal to 81. Two different ways to see that 3 raised up to the log base 3 of 81 is equal to 81. Either the clever way, where you kind of recognize that this 3 and this log base 3, loosely speaking, cancel out and you're left with just 81. Or more step by evaluating the exponent first, realizing that the exponent's 4, and then calculating 3 to the 4th power is equal to 81. You probably like that second method better. That probably seemed easier to you. But what if I instead asked you the question, what's 3 raised up to the log base 3 of 80? Now you're in trouble, right? Because you don't know the log base 3 of 80. What power do you have to raise 3 up to change it into an 80? I don't know. 3 squared is 9, 3 cubed is 27, 3 to the 4th is 81. 3 to what equals 80? I don't know, a little bit less than 4. But you never need to figure out what this number is. This answer is going to be 80, even though I don't know the log base 3 of 80. That's kind of cool. Anyways, with all of this as kind of a primer, we can evaluate this really easily. 3 raised up to the log base 3 of 2. Problem, you don't know the log base 3 of 2. The log base 3 of 2 is the power that you'd need to raise a 3 up to change it into a 2. What's that equal to? I don't know. It's some decimal. I mean, your calculator can figure it out if you really want, but it's nothing that's obvious. But you don't need to know what that is, because what you're doing is you're taking a 3 and you're raising it up to that magical exponent that changes 3's into 2's. So 3 raised up to the log base 3 of 2 is just equal to 2. Similarly, 5 raised up to the log base 5 of 9 is just equal to 9. Similarly, 8 raised up to the log base 8 of x is just equal to x. This question is really just asking you to solve 2 plus 9. That answer is 11. If you're a little bit comfortable with logs, specifically this identity that 3 raised up to the log base 3 of x just equals x, you can solve this question really quickly. But what if you can't? What if it's been a while since you've seen logs and you're not comfortable changing this expression to 2 and this expression to 9? How else could you solve this question? Well, you got a calculator. The only problem is your calculator may or may not allow you to calculate logs in different bases. Some TI-84s allow you to, some TI-84s don't. It depends on the operating system that's installed in there. The function you want is called log base. So it's not just this log right here, which assumes that the base is 10, or this ln, natural log, which assumes that the base is e. There's a third function called log base that allows you to put in any base, for example, 3 if you want. Unfortunately, this version of the calculator doesn't have it. The way you can see that is if you hit second and then 0 to get to the catalog where it lists all the different functions, and then jump down to the L's. If you scroll down here, you'll see some log stuff, natural log and log, but you won't see the log base function, which is unfortunate. That means I can't directly calculate the log base 3 of 2. However, even if you don't have the log base function in your calculator, you could still use your calculator to calculate logs by using the change of base formula. What the change of base formula tells you is that the log base b of x is equal to the log of x divided by the log of b. It actually tells you a little bit more than that, but for our purposes, this will be sufficient. How can you remember this? Well, change of base produces these fractions with 2 different logs in there. The 2 things you're going to use are the 2 letters you have here, the b and the x. The b is down in the base, so it kind of makes sense that it goes down in the bottom of the fraction. What I'm saying is if I want to calculate the log base 3 of 2 and I don't have the log base function, what I could do is calculate the log of 2 and then divide that by the log of 3, and the answer that I get will be equivalent to the log base 3 of 2. It's the change of base formula. So I pull out my calculator here, calculate the log of 2, close the parentheses, divide by the log of 3, close those parentheses, and what I have is the log base 3 of 2, like 0.63, give or take. What that's saying is the power that I'd need to raise this 3 up to change it into a 2 is 0.63. Don't believe me? Let's take a 3 and let's raise it up to an exponent. What exponent? Let's use the answer that we just calculated, that 0.630929. Second, and then this negative sign allows you to reference the most recent answer. If I hit enter, what I get is 2. What just happened? I calculated 3 raised up to the log base 3 of 2, and what I got for my answer was just 2. And that's not specific to 2s and 3s. If I do 5 raised up to the log base 5 of 9, I expect 9 to be my answer. Let's make sure that that happens. 5 raised up to some power. I'm going to open up some parentheses. That power should be the log base 5 of 9. I don't have the log base function in my calculator, so I can't directly calculate the log base 5 of 9. I instead have to use the change of base formula, which tells me that the log base 5 of 9 is the log of 9 divided by the log of 5. Log 9 divided by log 5. I'm taking a 5 and I'm raising it up to the log base 5 of 9. What I get for my answer, sure enough, is 9. Even if you didn't really understand logs, if you had this change of base formula memorized and you'd use your calculator a little bit, you might start to see some patterns. You might notice that this 3 and this log base 3, loosely speaking, cancel out and you're left with just a 2. And this 5 and this log base 5, loosely speaking, cancel out and you're left with just a 9. And you might therefore assume that this 8 and this log base 8 is going to kind of sort of cancel out and you'll be left with just an x, and that's exactly what happens. But if you couldn't, you could use your calculator to calculate this one and get 2, and your calculator to calculate this one and get 9, and then you'd have 11 is equal to 8 raised up to the log base 8 of x. How do you solve this equation? Well, one option is to take advantage of logarithmic and exponential form. Remember, we can always switch back and forth between these two different forms. If you think about the x as this 11 and the b as this 8 and the y as the log base 8 of x, then what you have here is an expression written in exponential form. And we can switch that into logarithmic form by saying the log base 8 of 11 is equal to the log base 8 of x. Probably have to go back and do that on your own, but convince yourself that these two equations are equivalent. The top one's written in exponential form, the bottom one's written in logarithmic form. Playing the role of the b is the 8, playing the role of the y is the log base 8 of x, and playing the role of the x is the 11. If you stare at this equation, the log base 8 of 11 equals the log base 8 of x, you might be able to figure out that, oh, 11 must be the same as x. It is. The answer is 11. A lot easier to come by that answer if you understand these identities. But even if you don't, if you know the change of base formula, you can get there with your calculator.